the applications of logarithmic differentiation is called the money stock problem. So the money stock problem is where we have this MD, this demand for money balances, and it's a function of multiple variables. In this case, Y being real income, R being an index of interest rates, and P being the prices. And it gives us this function. We're also going to start talking, though, about growth rates and percentage growth rates. So we want to recognize that in these problems, the rate of growth is the derivative with respect to time. And then if it talks about the percentage rate of growth, that the percentage rate of growth is the rate of growth divided by whatever variable we're talking about. So if this is the percentage rate of growth for M, it's the rate of growth for M over M. And what we end up with is that the percentage rate of growth is the derivative with respect to time divided by M. And sometimes we like to write this as M derivative over M. But this is giving us the percentage rate of growth. So no matter what question we get asked about the money stock, we're always going to want to do it the same way. We're going to start with whatever our equation is. So the equation from above, our M is equal to 2y to the 0.6, r to the negative 0.3, p. And we want to take the ln of both sides. We want to simplify this down. So if I take the ln, I'm going to have ln M is equal to ln 2 plus 0.6 ln y minus 0.3 ln r plus ln p. All we did, those exponents came down and out front. Multiplication became addition. And so now when we take the derivative, we are taking the derivative with respect to time. We are assuming that each one of these things is changing with respect to time. We don't need to write dm dt. We can write m prime, or dy dt. We can write y prime. We just want to recognize that these derivatives are all with respect to time. So we're actually taking an implicit differentiation with respect to time here, and it's always going to basically work out to be the same type of thing. So the derivative of ln m, 1 over that m times, what's the derivative of m? M prime. The derivative of ln 2 is just 0. The derivative of 0.6 ln y, 0.6 times what's derivative of ln y? 1 over y times, well, y prime. Minus 0.3, 1 over r, r prime, plus 1 over p, p prime. And here's the incredible thing about this. So you can write it like this. You could have also written it as dm dt instead of m prime divided by m equal to 0.6 dy dt divided by y minus 0.3 dr dt divided by r. We're just subbing in that those derivatives are the derivatives with respect to time. And the important takeaway here is that what we're left with is that this entire term is the percent change in M. And here I have the percent change in Y, percent change in R, the whole thing, and the percent change in P. And so whatever question they ask us, now we can answer it. So we actually now go back and read, what did A ask us? It says if real income grows, so real income being our Y, while the money stock and the price level remain constant, the interest rate must change at what rate? So this question is telling us that money stock and price level remain constant. They're not changing with respect to time. So I'm going to have 0 for that change in money stock, because money stock isn't changing. Price level is also not changing, and price level is our P variable. So my Y is changing. Again, it doesn't matter whether you're at Y prime or dy dt. My R is changing because R is my interest rate. But P is also not changing. Price level remains constant, so it's a 0. And this question asks us the interest rate must change at what rate? So the interest rate changing at what rate, it's actually asking us to solve for R prime. R prime is that rate of change of the interest rate. So it doesn't want the percentage, it actually wants the absolute rate. And we're just going to solve and rearrange for R prime there. So I'm going to have 0.3 R prime over R is equal to 0.6 Y prime over Y. I can multiply both sides by R. I can divide both sides by 0.3. And I'm going to be left with R prime is equal to 0.6 divided by 0.3 is going to be 2 Y prime R over Y. So this is telling us that that rate of change of the interest rate, given the fact that money stock wasn't changing, price wasn't changing, it's going to depend on Y prime, the value of R and the value of Y. We're just rearranging this equation, right? dr dt equal to 2 dy dt times ry, or R prime equal to 2 Y prime R over Y, depending on how you like to do it. So this is one way that they could ask it. The other way is where it actually gives us some percentages. So it tells us if the interest rate and indexing prices do not change, but real income increases by 5%, what's our percentage growth of the money stock? So remember, in our equation, that dm dt divided by m is equal to 0.6 dy dt divided by y minus 0.3 dr dt divided by r plus that dp dt divided by p, where each one of these terms is the percentage change. So we want to know what is the percentage growth of the money stock. So we're actually looking for this value here. If interest rate, so interest rate is R, so this doesn't change, and prices do not change. If multiple things were changing, we would just plug in multiple percentages there, and it's telling us that our real income has increased by 5%. If it had decreased, we put it in as a negative number. And so this is just that our percentage change in that money stock, right? This is that percent change in the money stock is equal to 0.6 times 0.05, so it is 3%. So under these conditions, the money stock would increase by 3%.